Hello friends, welcome to my channel. This is Isro question paper Engineering Mechanics Part 2. Which of the following is not a scalar quantity? Time, mass, volume and acceleration. Acceleration is a vector quantity. So D is our answer. A heavy block of mass m is slowly placed on a conveyor belt moving with speed. If coefficient of friction between block and the belt is mu, the block will slide on the belt through distance. How much? This one already discussed. Work energy principle we have to use. Here work energy principle we have to use. Work energy principle, sum of energy at position 1 equal to sum of energy at position 2. mgh is potential energy. This is potential energy at position 1. Kinetic energy at position 1. This is spring energy at position 1. This is force into distance work done. This is at position 2 potential energy, kinetic energy at position 2, spring energy at position 2. This is frictional resistance into distance. Here in this question, mgh potential energy, both position cancelled. Kinetic energy second position cancelled, no spring, force also no force. So half mv square at position 1 is frictional resistance into distance. So frictional resistance we know mu into normal reaction, mu into W is mg, half mv square equal to mu mg into distance. So the block will slide on the belt through distance. D we have to calculate. D is cancel, v square by 2 mu g. This one already discussed. V square by 2 mu g. D is our answer. A car moving with speed u can be stopped in minimum distance x when brakes are applied. If the speed becomes n times the minimum distance over which the car can be stopped, would take the value how much? So car is having kinetic energy, force into distance, half mv square. Same work energy principle. Force is mg into x equal to half mv square. Cancel. Then x equal to v square by 2g. So at second case x dash is n times multiplied, so nv square by 2g. It's n square into v square by 2g. It's n square into x. X already we got, v square by 2g. So from option car can be stopped, would take the value n square into x. D is our answer. Two blocks with masses m and capital M and small m are in contact with each other and are resting on a horizontal frictionless floor. When horizontal force is applied to the heavier, the blocks accelerate to the right. The force between the two blocks are how much? Take the free body diagram. bigger block having mass, smaller block, frictionless floor, so no friction. Here F is the applied force, small m here, so reaction are same reaction in this direction, it will move in this direction. So if we take combined body, both two, force F with acceleration A. So if we take combine one first, force F equal to ma, m plus m into A. For smaller one, small body, force is R is small m A. This is equation 1 and this is equation 2. From equation 2, we will get the value of A and put it in equation 1. Then we will get F equal to m plus m by into A. A how much? From equation 2 we will get R by m. So in this question, the force between two blocks, it's R, reaction R. R is F into small m divided by capital M plus small m. This is our answer. So from option D is our answer. Next question. This question also already discussed, second time asking. A stone of mass m at the end of a string of length L is wheeled in a vertical circle at a constant speed. The tension in the string will be maximum when the stone is tension, when it will maximum. Tension is the reactive force, so T at top position, body is m, downward mg weight of body, then centrifugal force m omega square r, T equal to mg plus m omega square, angular velocity is omega, m omega square r. So at top of the circle it's maximum. The ratio of radius of planets P1 and P2 is k, and the ratio of the acceleration due to gravity on them is s. Ratio of escape velocities from them will be how much? Escape velocity. Here data given are ratio of radius r1 by r2 is k, and ratio of acceleration due to gravity g1 by g2 is s. Here two formulas we are having. Escape velocity is 2gr root over. So v1 by v2, 2g1 r1 by 2g2 r2 root over. 2 cancel. g1 by g2 is s into r1 by r2 is k. S into k root over. B is our answer. But for same planet, one more formula is there. Here different planets, so we will use this formula. For same planet, V escape is gravitational constant, capital G, m by r whole root over. If you put this one, v1 by v2, 2g let G is same divided by 2G G1 by G2. So if M is same, this is R2, we will get G1 by G2 into R2 by R1 root over. So G1 by G2 is our S and R2 by R1 is 1 by K. So it will come S by K root over. If M is same for both planets, then our answer will come D. But in this question, the planets are different. So this formula we will use. Two particles with masses in the ratio of 1 by 4, 1:4 are moving with equal kinetic energy. The magnitude of their linear momentum will conform to the ratio. Third time asking in Isro. Many times repeated. Two particles with masses. So M1 by M2 is 1 by 4, equal kinetic energy. Half M1 V1 square equal to half M2 V2 square. Multiply M1 and divide M1. Here multiply M2 and divide M2. So M1 V1 by M2 V2 linear momentum square is M1 by M2. This is 1 by 4. So ratio of their magnitude of their linear momentum M1 V1 by M2 V2 is 1 by 4 root over it's 1 by 2 or 1:2. From option D is our answer. A roller of weight W is rolled over the wooden block shown in the given figure. The pull required just to cause the said motion is how much? Draw the free body diagram. Here its reaction will go in this direction W weight, in this reaction pull, it's P, here W, this direction reaction R. Finally this angle is 30 degree, so it's also 30 degree. P R W angle is 30 degree. So W equal to summation of vertical forces. W equal to R sin 30. It's R by 2. Summation of horizontal forces R cos 30 equal to P. In this question they asked P value. So or here R equal to 2W. So P equal to 2W into cos 30 is root 3 by 2. So 2 cancel, root 3 into W. B is our answer. A uniform circular ring of mass m and radius r is rotating with an angular speed omega about an axis passing through its center and perpendicular to the plane of the ring, two identical beads each of mass m somehow get attached at two diametrically opposite points, the rotational speed of the ring will become how much? Here we will use conservation of angular momentum. First, m into v1 into r1 equal to, in second case, two small masses having small m, v2 into r2. So v equal to r omega. We know v equal to r into omega. R is the angular velocity, v is linear velocity. We will use that one. We will get m into omega equal to capital M plus 2 into small m into omega 1 and omega 2. First one already given. This is omega. So this is m into omega, m plus 2m into rotational speed you have to calculate omega 2. So omega 2 we have to calculate. So omega 2 equal to m into capital M into omega by capital M plus 2 into small m. From option m plus 2, this one A is our answer. This is conservation of angular momentum formula, already discussed. An electric lift is moving downward with an acceleration g by 3. The vertical force between a passenger in the lift and its floor is equal to, this is also very important lift question, 4 to 5 times asked in Isro. Vertical force, this is vertical force R. This is the passenger from floor, vertical force is R, and this is W, moving downward with acceleration g by 3. So W minus R is W by G into G by 3. G cancel. We have to calculate R. W minus W by 3 equal to R. So R equal to 2 by 3 W, or 2 by 3 of the passenger's weight. From option, it's B is our answer. A body of mass 10 kg moving with a velocity 1 meter per second is acted upon by a force of 50 Newton for 2 seconds. The final velocity of the body is how much? Same work energy principle. Now here we have to use impulse momentum. So initial momentum plus impulse is plus impulse force into time equal to final momentum. In this question, mass is same, 10 into V is 1 plus force is 50 Newton into time is 2 seconds. Mass is same, so 10 into V2. Solve this question. 10 plus 100 to V2. We have to calculate final velocity of the body. It's 110 by 10, it's 11 meter per second. impulse momentum principle. So D is our answer. A car moving with uniform acceleration covers 450 meter in 5-second interval and covers 700 meter in the next 5-second interval. The acceleration of the car is, this one also second time asking, already discussed in my previous video. So directly I am doing S1 equal to 450 meter, T1 equal to 5 second, S2 you add 700 plus 450 is 1150 meter, T2 is 5 plus 5, 10 second. Acceleration we have to find out. So we will use S equal to ut plus half at square. 450 equal to 5u plus half, 5 square is 25a. Here 1150 S2 is 10 into u plus half into 10 second square is 100 into a. So here we will multiply 2, it's 900 equal to 10u plus 25a. Here 1150 equal to 10u plus 50a. From this one we will minus this one. If we will subtract, it will come 250 equal to 10 cancel, 50a minus 25a is 25a. So acceleration will get 250 by 25, it's 10. From option D is our answer. Thank you friends for watching my video. Thank you.